Hey guys, so today we're going to be looking at Waku protocol. This is something that's quite new to me. I only came across it within the past week or so. In short, it's a decentralized peer-to-peer messaging protocol with pretty close ties to Ethereum, well, originally, not anymore, as now it's blockchain agnostic. So, got a couple of slides here. I'm just going to go through, and then we're going to take a quick look at their pretty much most basic example they have on their, or the most basic example I can see on their GitHub. So, short history lesson. Whisper was an Ethereum peer-to-peer communication protocol, which has now been deprecated. It's part of the Holy Trinity. So there was Ethereum, the Ethereum network itself. There was Swarm protocol, which was for decentralized storage because storing everything on the blockchain didn't make sense. And there was also Whisper, which was the communication protocol. So Waku version 1 was released in November 2019, and it was created because it wanted to do what Whisper did, but do it a lot better. Special attention here to resource restricted devices. From my understanding, because I never used it myself, Whisper just was not viable to run on mobile clients on Ethereum. So if you're trying to use Whisper on a mobile phone, all your data would be used up because of the amount of upload and download from all the messages from the Gossip protocol. I think was the problem. But anyway, it just wasn't scalable. So Waku version 2 beta was released in November 2020, and it apparently is 10 times better or 10 times more performant than Waku version 1, which is obviously great for this resource restricted devices. So obviously they put a lot of work in performance in version 2. So what actually is it? As I said before, it's a privacy preserving peer-to-peer messaging protocol. It removes centralized third parties from messaging and enables secure censorship-free communication. If you go to their website, you can see they talk a lot about this and their motivations and goals. So the team are obviously quite big decentralization, privacy maxis, which I totally get. So yeah, it runs everywhere, desktop, server, on your mobile devices and phones now, and it's by the Waku Research Group, and this is funded by Status IM, which is a mobile app which actually has a decentralized app in it, which is, uses the Waku protocols. It's used in Status, like I just mentioned, Railgun, and XMPT, sorry. So the different implementations of it, there's JS Waku. This is the JavaScript one we're going to be looking at today. It runs in the browser. It runs a node in the browser. It seems, at least at a top layer, pretty simple to get into. And then there's MWaku, which is NIM Waku, Go Waku, Waku React Native for mobile devices, and Waku Rust bindings, which I think was just released a couple of days ago. I think I saw on the Discord. But yeah, I got all this information on waku.org. So if you want more, just go to that link. There's lots of good stuff on the website. So the different protocols they offer. The relay one is one of them we're going to be looking at today. So this is just to send and receive messages in a gossip-based manner. So this is a peer-to-peer protocol where messages will be sent out into nodes in the system, and they'll broadcast those messages just to all the nodes in the system. And then if you are listening for that correct content topic or for that correct message, then you will receive the message and be able to read it. Store, kind of similar to receiving the messages, except stores them when you're offline because it's not viable to keep the app running at all times. Light push and filter, for my understanding, these are for bandwidth constraints. So light push pushes it to a single node and receives an acknowledgement, and I assume what happens there, it uses the gossip protocol to broadcast it to the other nodes. I'm not an expert in this. This is my understanding anyway. And filter is so you only receive the messages on the certain topics, the content topics that you want. Waku message, this is just the standard format that's used, all Waku messages use, and we'll get into that in the next slide. And then Waku RLN relay, this is just spam protection, which on a network like this seems very necessary. The Waku message is composed of 4 parts. We have the payload, which is just the message content, the content topic. This is where the message should go, and we'll see how that's structured, or the recommended way to structure it from the Waku team and the code here. The version, which means it's clear or encrypted, and the timestamp is just simply the timestamp, just used for to know when the message was sent. So we're gonna hop over to Visual Studio Code here. So I will link this relay.js where it is in GitHub down in the description. I have the version here with all the comments, but I decided to take them out just because I wanted to go through the code myself. Just make sure I understand it without the comments telling me what's going on. Yep, it's just a basic HTML file with a JavaScript in it. Because the JavaScript from the Waku libraries will run the node in your browser, which is great. A couple of things were important here. Bytes to UTF data bytes. This is just for encoding and decoding, I believe. Create privacy node. This is for creating the node, and waveform up here. I'm still not exactly clear what this is, but we'll take a little look into it when we go a bit further down. Some HTML stuff. We're not going to look at that because this is on Waku. So the content topic, this is what we were talking about. This is the second part of the Waku message. The Waku team recommends that you structure your content topics like this. So this will be the dApp name, the version. I think this is the reason, or I can't exactly remember this part of it. And then the codec. And they recommend you use protobuf, which I guess is probably more performant, more scalable, but to simplify it a bit for this demo, they've just used UTF-8. So yeah, the encoders, create some encoders based on the content topic. Yeah, I was looking into what this actually means. Well, actually, we can look at it here. If we go to where's encoder used in the code. Okay, so when we send a message using the relay protocol, then I guess this is to encode it into a message that can be sent, and it takes in the payload, and the encoder has the what do you call it? The content topic in it, and then maybe you can pass in that third part as well to say it's clear or encrypted, and then the timestamp sets itself, I believe. So we'll go back up to the top here. So we just got a big try catch here in the JavaScript. So the first thing it does, it creates the privacy node. Okay. Right. Actually, we're gonna quickly go to the library for this. Okay, so it creates a Waku node that uses Waku Relay to send and receive messages and enabling some privacy preserving properties. Okay, so it creates it with default bootstrap true. I'm not too sure what that option means, so let's take a little look. Use recommended bootstrap method to discovery and connect to new nodes. I just realized I haven't opened it yet, so yeah, I should have done this at the start. So this is what it looks like. Yeah, so you have to have two clients open with two nodes if you're going to receive a message. So I'll wait till the second one connects, and then I'll just send some random message. We should see it in there. Yep. Okay, back to the code to understand how that's actually happening. Okay, so we create a privacy node. So this is creating the node, and then we start it up. After that, we add an observer. You can see in the observer, we add a decoder to decode the messages based on that contact topic, and we create the observer based on that contact topic. So from my understanding, I'll go to the ones without the comments so I can understand it. But I'll link it. I'll link it in the description. So if you want to read it through with comments or tinker with yourself, the examples are really good in their GitHub. This is just the most basic one, so I'm just trying to understand it. So yeah, you add an observer with the content topic, it looks like, which is what we looked at earlier. If the message doesn't have a payload, return. Oh yeah, I remember in one of the talks they said about, I think protobuf 3, now you don't have to have a payload for it, so this is a case that needs to be handled. Yeah, the text, yeah, we just changed it from bytes to UTF-8, the payload that's received. and then we add to, we increment or append, the new text that we receive onto the HTML. Okay, that makes sense. This part here, I'm gonna actually add it in my notes. Ask about wait for remote peer. I've asked a question before in the Discord and I got a really fast response, so I'm probably gonna just get some clarification on that. Or is there something in here which says, okay, best effort method that waits for the Waku node to be connected for remote Waku nodes peers and for appropriate handshakes to be done. Okay, so it just I get starting the node, but then I don't really know what other nodes I can find in the network if you only have one active, if you know what I mean. So if and by what I mean by that is if I open this and it says connecting to a peer, and then it can connect to a peer, but if this is the only instance I have running, why does it work? Wait, do I have one running here? No, I don't. Okay, but yeah, that's the question I gotta ask. Okay, so the next bit, we're just looking at the send button. Okay, so on click, what does it do? Converts the payload to bytes from the text input. Okay, makes sense. And then, this is the line we looked at earlier. The relay.send uses the encoder and adds the payload in. So I imagine that's just building up the message, the 4-part message that we saw earlier on in the slides. And then sets the value back to null after it sends. Makes sense. And then, this is just some HTML stuff after. Oh, okay, this is, when it's connected. When the remote peer has been connected, then the app is functionable. Okay, that makes sense. And then the try catch for it not starting. Okay, so I think I have a much better understanding of it now. It would probably take a little bit of digging into these to understand what's actually going on when it waits for the remote peer. Actually, can I do that now? Okay, I'm not going to do that in video, but I'll take a look at this after. But yeah, video was a bit all over the place. I was just wanted to, first of all, provide an introduction to Waku, and then take a look, just a little dive into the code myself, see how it works, see it working. That was pretty much all I wanted to add onto that. I wasn't sure if I planned on it being that technical, or that's, it wasn't that deep a dive because it's only one little HTML file, but I think that's provided me with a good base to go through the other examples now that I kind of have an understanding of the relay and the messaging part of it. But yeah, it's good, and I'm gonna definitely ask some questions in Discord just about stuff I don't understand, because I just need to bottom out some of that. But yeah, if you got this far, thanks for watching. I had a nice time going through the code. So, yep, cheers.